Okay, here we're going to look at parametric equations and how to differentiate parametric equations. Now, parametric equations are actually kind of cool. It's where there is one thing that affects both x and y. So here's an example. X equals t plus 2 squared and y equals 3t. Okay. To graph this, we're going to end up making a table that looks at t, x, and y. All right. So we start off with t at, say, -3, -2, -1, 0, 1, 2, 3. So when t is -3, all right, that is our first bit here. -3 plus 2 is going to be -1, squared is 1. All right, so that's going to be 1. And our y is 3 times that, it's -9. Our x, when t is -2, it's going to become 0. It's going to be -6. All right, when -3, 2 squared is 4, 0. All right, and hopefully we can see the pattern here. Oh. 25, and that's going to be 3, 6, 9. So we'll graph it, it'll look something like this. So we'll just plot a couple of these points. We've got 0 and -6. We'll say that somewhere like that. We've got 1, and we've got -3 and -9. 4 is going to be 0. -3 should be about halfway between, so it should be about here maybe. Like there. And we could plot the rest of the points, but it's not going to fit on our graph here. So it looks something like that, sort of like a sideways parabola. Okay, if we want to differentiate that, it gets a little bit tricky because it's hard to actually put that equation in a form that's useful. So what we can do is we can differentiate to find dy over x. We can use the chain rule because everything is the chain rule really. And we can differentiate each of the parts. So we can find dt, or dx over dt. dx over dt, which is going to be 2 lots of t plus 2. And then we find dy over dt, which is going to be 3. Okay, then after we do that, we can put it together. Now, eventually we want it to be in terms of x, so we're going to have to figure out what our x is here, but we'll get there in a second. All right, now dy over dt times dx over dt is not actually going to give us dy over dx. To find that, what we need to do is we need to flip that up. So this means that dt over dx is going to be 1 over (2t plus 4). Just expanding that because it's going to be useful to do that. So dy over dx is going to be dy over dt times dt over dx. So we get dy over dx equals 3 over 2t plus 4. Now for the time being, that's as good as we need. Right, so 3 over 2t plus 4. And so for whatever t is, we can figure out what dy over dx is. Let's have a look at another example. Okay, we're going to have a look at this one here. X equals log of 4x, also have it, 4t squared plus 3, and y is equal to the square root of t. Right, so we can draw up our little table. Right, now we've got some particularly nasty numbers in here. Right, so we're going to have to actually bang some things into our calculator in order to be able to get these ones. So we start off with t is negative 2. Well, negative 2 squared is 4, times 4 is 16, so we can start off with log of 19. Alright, so log of 19, that's 2.94. 2.944. Y is going to be the square root of 2, or square root of negative 2, which of course is undefined. So we actually don't need to worry about the negative ones. Right. For 0, we're going to have log of 3. So 1.099. And when y is that, we're going to have the square root of 0, which is 0. When t is 1, that's going to be 1. That's going to be 1.414. Okay. Right, so then we have to put in 1 in here. So 1 squared is 1, 4 plus 3 is 7. So we're going to find the natural log of 7, which is 950. Sorry, 946. 1.946. And then with 2, obviously we figured that out before, it's 2.944. So we can graph this. So we start off with x is 1, y is 0, then x is 1.9, y is 1. X is 2.9, y is 1.44. I'm going to get something that looks a little bit like that. Right, so to differentiate this, we've only got a particular range that we can differentiate it, which is when t is greater than 0, in which case y is going to be greater than 1, greater than 0, and x is going to be greater than 1.099. Right, so to find it, we first of all are going to find dx over dt. Then we'll find dy over dt. And we'll put those two together to find dy over dx. So dx over dt, well, it's 1 over 4t squared plus 3 times by what's inside, the differential of what's inside, which is 8t. Right. This one's nice and easy. It's 1 over 2 root t. Okay. So to clarify, that one is going to be 8t over 4t squared plus 3. Okay. Now, this is where it starts to get a little bit more interesting, because when we differentiate it, we're going to be flipping this one on the top to get dt over dx when we're putting them together. So, dy over dx equals dy over dt times dt over dx. So, dy over dx equals dy over dt, which is 1 over 2 root t, times, and then we flip this up, 4t squared plus 3 all over 8t. Right. So altogether, dy over dx equals 4t squared plus 3 over 16 t to the power of 3 over 2. Right, and that's pretty much what we're going to get. Now, if we wanted to know what is the gradient, if we wanted to know a tangent where t equals 1, for example, or maybe t equals 2 might be better. We'll use t equals 1. Gradient where t equals 1. So when t equals 1, we know x is 1.946 and our y is 1. And the tangent okay. So the first thing we'll do is we'll find the we'll differentiate. We've differentiated it already. We'll find out. We'll substitute that into the differentiated function, and so we'll find that dy over dx equals 4 lots of 1, which is 1 squared, which is 4, plus 3 is 7. 16 times 1 is 16. So we've got 7/16. Right, and so that's our gradient. And the equation of the tangent is y minus y1 equals m x minus x1. And so therefore we have y minus, let's have a look, y minus 1 equals mx minus 1.946. $496,946. And then we could simplify that to get what our answer is in terms of a y equals mx plus c. But overall it gives us a fair idea as to what we've got to do from there. So that's the using parametric equations. Now they do make some pretty cool graphs. So let's have a look at some of these. We'll do 2 questions today. Okay, we're going to do 2 questions today. Question 1. Find dy over dx, where y equals 3t and x equals sine t. Okay, question 2. Find some German. Find the equation of the tangent to y equals 3t squared x equals 1 minus t, 4 minus t, all squared. That's a 4, not a 14. Where t equals 1. So we want to find the tangent to that equation where t equals 1.